One of the biggest and most common misconceptions is that people think that acceleration being negative necessarily means that the object is slowing down. What I want to do with this video is show you that this is not the case. So for the whole experiment, we're going to call the right direction the positive direction. And we're going to start by having a person running towards the right and starting with a velocity of 2 meters per second. And then it's going to increase to 6, then to 10, and then to 14. And this is broken into intervals of 1 second. So because this person is running towards the right, all of these velocities must be positive. So let's calculate the acceleration. We know acceleration is the change in velocity over the change in time, which means final velocity minus initial velocity over the total time. And in this case, it's going to be positive 14 minus positive 2 over the total time, which is 3 seconds. That is going to give us positive 12 over 3, which gives us positive 4 meters per second square. So in our second scenario, we're still going to have the person running towards the right, but now it's going to start at 20 meters per second. And then he's going to slow down to 15, to 10, and to 5. Since he's still running towards the right, all of these velocities will be positive. So let's calculate acceleration again. So now our final velocity is going to be plus 5 minus our initial velocity, which is plus 20, over the time, which is still 3 seconds. So that's going to give us negative 15 over 3, which is negative 5 meters per second square. Now for our third case, we are now going to start running towards the left. And this person is going to start at 2 meters per second, then increase to 8, then to 14, and then to 20. So because now he's running towards the left, all of these velocities will have a negative sign in front of them to indicate that direction. So let's calculate acceleration again. Now our final velocity is going to be negative 20 minus our initial velocity, which is going to be negative 2 over the 3 seconds. So that's going to give us negative 18 over 3, which is negative 6 meters per second square. In our final case, we're going to start moving at 20 meters per second, then slow down to 18, 16, and 14. So our calculation will look like this. Our final velocity will be negative 14, because all these velocities should be negative as well, indicating that we are moving towards the left. Minus our initial velocity, which is negative 20, over 3 seconds. That's going to give us 6 positive over 3, which gives us positive 2 meters per second. Sorry, it was meters per second square. So I've numbered our cases 1, 2, 3, and 4. If you look at case 2, we indeed have a negative acceleration that is indicating that we are slowing down as we go from 20 to 15 to 10 and to 5. But if you look at case number 3, we also have a negative acceleration, even though in this case we are speeding up. We're going from 2 to 8 to 14 and to 20. So this should show you that a negative acceleration doesn't necessarily mean that the object is slowing down. So what can we do to figure this out? Luckily, there is something we can do to figure out if the object is speeding up and slowing down reliably. So notice that case 1 and case 3 are both speeding up. And case 2 and case 4 are both slowing down. So what's common between them? And this is the rule that you have to remember. In order for an object to be speeding up, the signs of the velocity and the acceleration must be the same. And in case 1, we have both of those signs being positive. And in case 3, we have both of those signs being negative. So if the signs of both the velocity and the acceleration are the same, then your object will be speeding up. And if they are different, like in case 2, where the velocity is positive and the acceleration is negative, or in case 4, where the velocity is negative and the acceleration is positive, then your object will be slowing down. So now let's put it in words. So the first conclusion is an object will be speeding up when the velocity and the acceleration have the same sign. And the second conclusion is an object will be slowing down when the velocity and the acceleration have different signs. So the misconception that a negative acceleration on its own guarantees that the object is slowing down is incorrect. And we must remember that we have to consider both velocity and acceleration to make that conclusion.